evolution of general relativity to Einstein-preferred perfection based on Einstein's two dictums and guidelines. Presentation, dictums and guidelines. Here, we have presented a table which shows orbital precision computed for 5 planets and moon at sub-microsecond accuracy using 3 independent methods. In the first 3 columns, there are 3 methods. The value of the orbital precision in arcsecond is given: first method, second method, third method, 3 columns. Fourth column is giving the highest mismatch between any 2 of the columns in arcsecond. Next column is showing the same highest mismatch in microarcsecond. It clearly shows in this column that we have done even really 1 order of magnitude better than microarcsecond, because in the first decimal, after the decimal point, all are having 1 0. That means it is 1 order of magnitude better than sub-microarcsecond. And here we are showing what are the planets: Mercury, Venus, Earth, Mars, Jupiter and the Moon. This reference is given of a paper published in a peer-reviewed international journal, whose link is given here. Can we still think that space is curved, that is non-Euclidean, after seeing these very accurate precision angles computed by Ether for 5 planets and the Moon, utilizing Euclidean geometry and using 3 independent methods? Abstract. Biggest fallacy relating to general relativity, GR, that is GR. Most proponents of GR think that now there exists only one version of GR, but actually there exists more than one version of GR. Each of them is coexisting with others. Some authors and lecturers even think that their version of GR is Einstein's GR. Though these don't match its exact features given in the page below. For achieving this status, they need to apply all Einsteinian concepts, dictums and guidelines as mentioned by Einstein in his books and articles, as has been explained with references below. Einstein's first generation GR. EGR, that is default general relativity, followed truly Einstein's GR, 2 dictums and guidelines, and adopted nature's preferred orbital model and could achieve sub-millimeter positional accuracy of the Moon. Before the space age, Einstein had no option but to adopt the principle of covariance based on contemporary knowledge, that is due to legacy of Galilean relativity principle. Though he needed to give up the Euclidean geometry, so Einstein struggled. Reference J.Bernstein, a 1976 biography of Einstein, stated that Einstein struggled to overcome his dilemma till 1912 and finally stated, before incorporating the concept of relativity of all frames in GR, that there is no way of escape from the consequence of non-Euclidean geometry. All frames are participle. Reference of Einstein's evolution of physics book is given here, 1938 publication. Link is given. Exact features of Einstein's first generation GR. Most important feature of Einstein's first generation GR are the variable speed of light due to influence of variable gravitational field as referenced below and relativistic time. Whereas Einstein adopted, due to legacy of general relativity principle, non-Euclidean space that changed in space age according to Einstein's first dictum to Einstein-preferred Euclidean space, as nature's preferred frame had been found to be the only choice for high precision celestial orbits of planets and the Moon by both JPL, that is Jet Propulsion Laboratory, Caltech, NASA, etc., that is third generation GR, and EGR, that is default general relativity. We hope that numerical simulation of that by the recent generation of GR conventional model will help merging GR all generations into Einstein-preferred GR of Bartman and Hector, that is GR conventional model. GR conventional model is concentrating on astrophysics and cosmology that relates mostly to faraway universe, both in distance and time. They need to work also on the gravitational problem for computing sub-millimeter better positional accuracy of the Moon with respect to its nature's preferred frame or any other frame. Their recent generation is already using numerical relativity elsewhere, and 2. On computing the frequency shift of terrestrial clocks due to shifting from a laboratory at a lower elevation to a laboratory at a higher elevation on the Earth, which is an experimental proof for Einstein's concept on the variable or coordinate speed of light CR. The main features of this model, here conventional model, is here equation, non-Euclidean meter, ofSpace, constancy and relativistic time. Third generation here astronomers model, JPL, NASA, etc. Here astronomers model, that is JPL, NASA, Harvard, CFA, Leibniz University, Germany and IPCC, France, etc., which is able to compute lunar positional accuracy but are not able to bring it down below 10 mm over a few decades. However, they found out that the concept of relativity of all frames is invalid and it needs to be replaced by the concept of nature's preferred frame. However, till date, they are using non-relativistic time for doing numerical integration of lunar and planetary orbits. Whereas, since 2016, they have started using relativistic time for their deep space artificial mission, that is DSS mission. The main features of their astronomers model are their equation, Euclidean meter, no curved space, constancy and non-relativistic time. Determines the constancy of their astronomers model and the their conventional model had already been invalidated experimentally by the detection of delta C as frequency shift delta nu in terrestrial laboratories in USA and Japan. Note, for example, delta C equal to lambda into delta nu equal to 0.000034 meter per second has already been detected as frequency shift delta nu equal to 48 Hz of 87 strontium clock as determined at LSM lab France with respect to INRIM lab Italy located at elevations differing by about 1 kilometer. As JIPM 2015 recommendation specifies a fixed wavelength lambda for 87 SR equal to 0.698 micrometer. Reference is given of a journal 2018 journal. Links are given. Constancy, it will be noted that is not Einstein-preferred. Constancy is not Einstein-preferred. All lab determined frequency shifts delta nu of earthly clocks are experimental proofs for EDR. EDR main features are EDR equation, Euclidean meter, no curved space, variable C and relativistic time. Experimental proofs for EDR continued. EDR enabled computation of an order of magnitude more accurate value of 1983 adopted terrestrial field as 299792458.5 meter per second at the NIST lab location directly proven independently by NIST lab USA, NPL National Physical Laboratory UK and NRC National Research Council Canadian lab. Their determined value is 299792458.6 plus minus 0.3 meter per second. Reference of a journal of 1983 is given here. Based on this EDR computation and its verification by NIST and to other renowned labs, we propose for revision of the 1983 adopted magnitude of terrestrial C by one order of magnitude, that is as 299792458.5. Its link is given and reference of the paper is given. DOI link is given. Lunar positional accuracy is the most recent proof of EDR. Most accurate LLR lunar laser ranging initiative from Apollo Observatory is Apollo Observatory is Apache Point Observatory for lunar laser ranging operation. Is the Apollo Observatory. He is demonstrating at present sub-millimeter range positional accuracy. Monty, principal investigator of Apollo, stated in 2009 that they will explore which model or code is worth putting their efforts into, and that among the 4 available LLR simulation models, JPL, Harvard CFA, LU Germany and IMPC France, the JPL model currently produces weighted RMS root mean square residuals at about 18 mm. Till date, they have not improved much, whereas EDR incorporates the real orbital model that nature uses simultaneous and precisely to conserve the orbital angular momentums m theta and m phi, both magnitudes and directions. This helps EDR to achieve sub-millimeter positional accuracy of the moon in geocentric orbit. The main body of the presentation titled Evolution definition of general relativity to Einstein-preferred perfection based on Einstein's two dictums and guidelines. Introduction. The presentation describes the three major versions of general relativity, that is their models that exist now in a tabular format. To make it easy and convenient to compare them with each other, relativist Professor Samuel summed up from his own observation on the history of the Earth by stating that there was a period of hibernation from 1920 to 1960 during which theoretical work temporarily outstripped technology and experimental possibilities, and as a consequence the field stagnated and was relegated to the backwaters of physics and astronomy. Reference Will CM, Living Reviews in Relativity. There are two links given here. Second one is a PDF link. Thereafter, during next 6 decades, GR has grown into independent branches. Finally, during 21st century, the following two experimental and or observational breakthroughs have been achieved that have brought an opportunity when some more effort can merge the different GR models into one Einstein-preferred perfect model based on Einstein's two dictums and guidelines. First one is sub-millimeter positional accuracy of the moon, which is the most accurate observational accuracy achieved in the solar system, has been accomplished from LLR, Lunar Laser Ranging Initiative, named Apollo Observatory, Apache Point Observatory Lunar Laser Ranging Operation in New Mexico. Now that even GR conventional model is using n-body simulation codes, all the GR models need to match this sub-millimeter positional accuracy of the moon using their n-body simulation codes after suitably modifying them based on the tips given here, based on Einstein's two dictums and guidelines. Number 2, variable C has already been detected as delta C equal to lambda into delta nu equal to 0.000034 meter per second. Where frequency shift delta nu equal to 48 Hz of 87 strontium clock as determined at modern underground lab, that is in short called LSM lab, France. With respect to INRIM lab Italy, located at elevations differing by about 1 kilometer. Reference is given of a paper by Grotti et al. Its link is also given here. As DIPM 2015 recommendation specifies a fixed wavelength lambda for 87 SR equal to 0.698 micrometer. Detection of delta C in several other terrestrial laboratories in USA, Japan, etc. are clear proofs of the Einsteinian contention that C is variable due to effect of variable gravitational field. Reference of a paper is given here with link. Here there are three main columns, first, second, third. The middle column is meant for first generation GR of Einstein. In a 1911 paper titled On the Influence of Gravitation on the Propagation of Light, published in 1911, English translation link is given here. Einstein expressed the equation for the variable speed of light. In a 1912 paper, titled The Speed of Light and the Statics of the Gravitational Field, analyzed that is a German paper, but English translation link is given. Einstein stated that the principle of the constancy of the velocity of light is valid only for space-time regions of constant gravitational potential. In 1916, Einstein's GR paper was published in Analyzed Physics, volume 49. In Einstein's 1920 categorical statement reference relativity as special and general theory, authored by Einstein, in reference has been given here. As one of the few inferences from the general theory of relativity stated that the law of constancy of C in vacuum, which constituted one of the two fundamental postulates of the special relativity, that is SR, was not valid according to the GR, as curvature of light rays can only occur when C varies with position. Einstein further stated that SR cannot claim an unlimited domain of validity, and its results are valid only so long as it is possible to disregard the influences of gravitational fields on the phenomena of light propagation. In 1921 calculation of light deflection angle, reference is given up with link. Also, Einstein used an equation involving variable velocity of light L. Important features of Einstein's gear have been summed up here. Most proponents of gear have not considered the above mentioned four statements from Einstein. On the contrary, they consider that C is constant. Whereas, as clearly stated by Einstein himself, over a period of 12 years from 1910 to 21, variable speed of light due to the influence of variable gravitational field as referred above is the most important feature of Einstein's gear. To make any of the gear models develop into Einstein gear, the proponents of each gear model need to apply Einstein's concept on variable C and Einstein's two dictums and incorporate the implications of the recent experimental detections of delta C as frequency shift delta knowing terrestrial laboratories around the world. And number two, observational data from Apollo Observatory in New Mexico by doing numerical simulation for computing sub-millimeter or better positional accuracy of the moon with respect to its nature's preferred frame or any other frame. Now we go to the third column. There we have given the important features of gear's astronomers model, which is been called here third generation gear astronomers model. That is gear astronomers model. Important features are gear equation, 1983 Euclidean meter, no curved space. SR, that is special relativity, constant C, non-relativistic time. These are the main features of gear astronomers model, JPL, NASA, etc. We have mentioned other groups earlier, other institutes. They use nature's preferred frame because they also could not find any other alternative frame. Now we go to the first column, the second generation gear of Boltzmann and MPW. MPW is Misner-Thorne-Wheeler model. The main its important features are gear equation, non-Euclidean meter, curved space, SR, that is special relativity constant C and relativistic time. And the whole thing is called gear conventional model. Is known as gear conventional model. Sometimes it is called MPW model also. The space-age scenario helped astronomers of JPL, NASA and EDR to apply the space-age tool of numerical simulation and ranging data for planetary and lunar orbits, making it clear that there exists no other alternative but to accept nature's preferred frame as the only reality. Before the space-age, Einstein had no option but to adopt the principle of covariance based on contemporary knowledge, that is due to legacy of Galilean relativity principle, though he needed to give up the Euclidean geometry. So Einstein's struggle, as stated by Bernstein in Einstein's biography, that he struggled for more than 5 years to overcome his dilemma till 1912 and finally stated before incorporating the concept of relativity of all frames in gear that there is no way of escape from the consequence of non-Euclidean geometry if all frames are permissible. This is given in his book Evolution of Physics, authored by Einstein in 1938. But now after applying the numerical simulation for planetary and lunar orbits, it became clear to astronomers of JPL, their reference of 1983 paper is given of JPL and EDR or RRT reference of the 2007 paper is given here. It became clear that but to accept nature's preferred frame as the only reality. So it is time for all relativists to apply the concept of nature's preferred frame by doing numerical simulation of planetary and lunar orbits and convince themselves that space is not curved but Euclidean. Thus all the gear models will merge and become more advanced. Boltzmann did not carry forward the Einsteinian concept of variable C in his flagship book titled Introduction to the Theory of Relativity, published in 1942. However, after about a quarter century, in connection with the magnitude of C, he stated in his 1968 book titled The Riddle of Gravitation, reference with link is given, the following. First bullet, by the same token, an outside observer would never be able to see an event that took place inside Schwarzschild radius because the light signal emanating from such an event would not reach him within any finite time, and not any particle but also light rays experience a slowdown near the event horizon of a black hole, and here predicts that a pulse of light operating from any height outside the Schwarzschild radius of a large mass will take an infinite time to reach it. Barton did not support or carry forward the Einsteinian concept of variable C because he could feel that this concept is not compatible in combination with the two concepts of non-Euclidean or curved space and relativistic time. Note, we could understand this based on our work and a quarter-century long experience of ephemeris generation while developing Ether. It may be mentioned here that Bergman also stated in his 1968 book titled The Riddle of Gravitation, link is given, that Gier has brought about a serious complication in the concept of observable quantities because of its adoption of the principle of general covariance, that is the concept of relativity of all frames. He specifically mentioned about the complicacy involved by stating that, for instance, the curvature having as many as 20 different components varies from point to point, and second bullet, a particular world point may be identified in terms of the values of several components of the curvature and also in terms of other geometric quantities, assuming particular numerical values such as the rate of change of the curvature per unit distance in various directions, etc. Bergman's conclusions regarding the facts as mentioned above with reference that velocity of light is variable and that Gier has brought about a serious complication in the concept of observable quantities because of its adoption of the principle of general covariance, that is the concept of relativity of all frames, as stated in his 1968 book titled The Riddle of Gravitation, were not however carried forward by the next generation relativists in their 1971 book titled Gravitation. Now we come back to the middle column, that is Einstein's Gier. Einstein became a professor in the School of Mathematics at the Institute of Advanced Study in Princeton University in 1933. Einstein's two dictums are mentioned here with reference. Keeping the puzzling nature of relativistic principles in mind, Einstein as a scientist dedicated the following two dictums roadmap for future generations to make his Gier evolve to perfection, or in his own words, get nearer to the grand aim of all science. His first dictum, reference is given, titled The Problem of Space, Ether and the Field in Physics, published in Ideas and Opinions, reference is given with link, states that the theory of relativity is a fine example of the fundamental character of the modern development of theoretical science. The initial hypothesis becomes steadily more remote and abstract from experience. On the other hand, it gets nearer to the grand aim of all science, which is to include the largest possible number of empirical facts by logical deduction from the least possible number of hypotheses or axioms. His second dictum, published with the title Principle of Theoretical Physics in the same book, Ideas and Opinions, reference and link is given, states that it may equally well happen that clearly formulated principles lead to conclusions that fall entirely or almost entirely outside the sphere of reality at present accessible to our experience. And in that case, it may need many years of empirical research to ascertain whether the theoretical principles correspond with reality, and we have an instance of this in the theory of relativity. With great foresight, Einstein anticipated difficulties or problems in applications of an abstruse theory like Gier about a century ago and stated the above mentioned two dictums for future generations, so that based on experience of long continued experimental verifications, more and more empirical facts can be incorporated while replacing the previously adopted hypotheses or postulates with only experimentally proven principles, in order that his relativity theory can evolve to perfection to get nearer to the grand aim of all science. During this period, Einstein also traced the development of the concepts in physics and relativity theory in his 1938 book titled The Evolution of Physics, the growth of ideas from early concepts to relativity and quantum. The authors, this book has been authored by Einstein and Leopold. The authors have earlier published a paper. The authors of this paper, Simulation Model for Shapiro Time Delay and Light Deflection Experiments, published in 2004, have earlier published a paper that a beam of light will bend in a gravitational field. Have published a paper that utilized an Einsteinian concept that a beam of light will bend in a gravitational field exactly as a material body would if thrown horizontally with a velocity equal to c, and reported the numerically simulated values that was based on the 1983 adopted magnitude of terrestrial sea, and that compared well with the corresponding experimental results of time delay observed during the two sets of Shapiro time delay experiment conducted in 1976-77. Bergman adopted speed of light c as a constant. Bergman did not support or carry forward the Einsteinian concept of variable c because he could feel that this concept is not compatible in combination with the other two concepts of non-Euclidean or curved space and relativistic time. The term Serepak in the following text will refer to century-long experience of relativity-related experiments on physics, astronomy and celestial mechanics. In the pre-Serepak scenario, Einstein had no option but to adopt the principle of covariance based on contemporary knowledge due to legacy of Galilean relativity principle, though he needed to give up the Euclidean geometry. So Einstein struggled for several years and finally stated before incorporating the concept of relativity of all frames in here that there is no way of escape from the consequences of non-Euclidean geometry if all frames are participle. It will be mentioned here that as mentioned at the left hand side column, Bergman also stated in the relativity of gravitation that GR has brought about a serious complication in the concept of observable quantities because of its adoption principle of the principle of general covariance. The above two opinions support easiest adoption of nature's preferred frame and easiest getting rid of the hypothesis of equivalence principle Dictums and being equipped with Serepak and the sophisticated space tool of numerical simulation. Thus, easier could revive Euclidean space. This was subsequently proved from the computation of precisional data for the 5 solar system planets and the moon. This data can be seen in table 1 given below and in a larger format at the end of the presentation. At the beginning, we have shown this table in a shorter form. Following Einstein's dictums and being equipped with Serepak and the sophisticated space tool of numerical simulation, it became possible for EDR to replace the experimentally unverifiable Max principle using the law of conservation of momentum vector direction, which provided the much desired generalized law for spinning and rotational motions, which had been experimentally proven in both their macroscopic and microscopic realms. The year 1983 has a special significance for a few reasons. In modern physics, C gained a more important status among the fundamental constants of nature, and many unfound experiments were conducted for its determination till 1983, when it was frozen at a fixed value after determining it up to an accuracy level of a fraction of a meter per second. The value was 299792458 meter per second. But even after almost half a century of space-age experimentation on various aspects of light and relativity theory, no experiment has been so far been conducted to determine truly local speed of light at locations closer to the sun. We have published a paper for execution details of this experiment, and a link is given here. EGR computed the lower limit in nature for CR, which is a more accurate magnitude of C0 given by 299792458.3 that corresponds to a 10-digit accurate magnitude of terrestrial sea. Minimum value of terrestrial sea. But based on this computed value of C0 given by 299792458.3, the next step of computation by the computation of the local values of CR at NIST lab, that is located at Boulder, USA, Colorado, USA, led to a 10-digit accurate value of 299792458.5 meter per second. Incidentally, this was the location where Jennings et al. Published in 1987 determined the most accurate magnitude of C as 299792458.6 plus minus 0.3 till date. Since then, no further this value have been determined also by other two labs as mentioned earlier in UK and another was in I think Japan. So this number, exactly same numbers they have got. Since then, no further laboratory determination of C has been reported. This was a very significant time for a possible spark in the evolution of gear, taking advantage of the space age developments and precision, as National Aeronautics and Space Administration, that is NASA, was founded in 1968 and JPL, Jet Propulsion Laboratory, was transferred from the Army to NASA. The space age began with the first successful interplanetary journey in 1962 of the JPL-built spacecraft Mariner 2 that flew past Venus. Dr. E. Miles Standish Jr. obtained his PhD degree in 1968 at Yale University with a thesis. Early work at Yale University Observatory concerned celestial mechanics and mathematical astronomy. He joined JPL Caltech in the 1970s and continued his work there until his retirement in 2006. His group worked and is still working at JPL for developing the various versions of JPL planetary and lunar numerics using the GR astronomers model as explained in the following section. It uses GR equations and methods of high or double precision numerical simulation. It is noteworthy to mention that at the beginning, in the 1990s, we wrote to the director JPL, and based on his advice, Dr. E. Miles Standish Jr., head of Ephemeris division at JPL, Jet Propulsion Laboratory, Caltech, NASA, helped us much for the first few years by providing with data, preprint of his published papers and advice, etc. We are thankful for this help and have acknowledged about it in all our published papers in peer-reviewed international journals. Dr. Standish retired in 2006. So now we come to the middle column. We started our numerical simulation model or code following the JPL way that computes the resultant gravitational acceleration of an orbiting body O and then integrates it in two steps to get the velocity and position coordinate of O after a small time interval. Repeating this procedure, they ultimately reach the ending pericenter of the orbit. But we added a parallel section that computes the corresponding centrifugal or inertial accelerations and checks that they compare well with the corresponding centripetal, that is the resultant gravitational acceleration. This methodology of comparison has helped us to understand the real nature of centrifugal or inertial accelerations and inertial drops as given by the law of conservation of vector direction of momentum vectors as given at appendix of RRT paper of 2007. Link is given here. In easier RRT model, the left hand side and the right hand side parts of the equations of motion respectively of the gravitational and the inertial acceleration The equation for inertial acceleration in easier RRT model are obtained from the generalized law of rotational motion. The left hand side part of this equation of motion, which is similar to JPL's equation of motion consisting of the resultant gravitational acceleration due to the n-body effect, is written with respect to the relevant natural CS and is numerically integrated to obtain the epoch-wise position and velocity vector data of any orbiting celestial body of the solar system. The ordinary differential equations ODEs corresponding to the Arrhenius part of this equation of motion consisting of the inertial accelerations are numerically during all stages of epoch-wise calculations. This procedure ensures that the methodology of nature is being followed in each year. From the space's ephemeris generation experience and while following nature's way to conserve energy and momentum, the authors found sufficient reason to replace the concept of relativity of all frames with that of nature's preferred frame. JPL and other followers of dear astronomers model also found to be true, as stated by Dr. Standish, that it has proved numerically more suitable to integrate the lunar ephemeris related to the Earth rather than to the solar system medicine. This helped the authors to escape the dilemma faced by Einstein still 1912, and then when he concluded that there is no way of escape from the consequence of non-Euclidean geometry, all frames are permissible. From our simulation jobs, we realized and established that the precision positional data for the planetary or satellite orbits can be fitted only in the nature's preferred frame of the orbiting body. For example, ECI or Earth-centered inertial frame, or the ECSF or the Earth-centered space fixed frame for the lunar orbit, and that such data cannot be fitted for any other alternative frame. That is, for example, a heliocentric lunar orbit or a lunicentric Earth orbit using the positional data of the Earth and the Moon is not possible. Note, in this connection, Standish et al. In their paper, 1983 paper, stated that it has proved numerically more suitable to integrate the lunar ephemeris related to the Earth rather than to the solar system medicine. This mathematically accurate result helped in the spaces to get rid of Einstein's compulsion as regards the relativity of all frames, and thus helped to bring back Euclidean geometry in EGR or RT. It may be mentioned here that most of the complexity of ER, as also specifically stated by Bartman in his 1968 book as mentioned above, was due to the unavoidable adoption of the principle of covariance based on contemporary knowledge, which led to curved space and non-Euclidean geometry, and which was neither liked by Einstein nor by Bartman, as mentioned later in 1968, as explained earlier. The relativistic transformation factor for time, formulated in 2007 and employed in RRT for EGR, as mentioned in RRT paper of 2007, happens to be identical to that developed later by JPL in 2016 for their Deep Space Atomic Clock mission or DSS mission, presented in a JPL Deep Space Atomic Progress Report, Deep Space Network Progress Report. The reference is given here with link. Due to the effect of the local gravitational potential energy level of the local gravitational redshift factor FR, which relates to the photon's local speed CR. Experimental proofs and space experiments proposed for EGR. EGR enabled computation of an order of magnitude more accurate value of 1983 adopted terrestrial C as 299792458.5 meter per second at the NIST lab location, directly proven independently by NIST, National Institute of Standards and Technology USA, NPL National Physical Laboratory UK, and NRC National Research Council Canadian Labs, determined value 299792458.6 plus minus 0.3 meter per second. Reference of a 1983 paper is given here with link. Based on this EGR computation and its verification by 3 renowned labs, EGR proposed for division of the 1983 adopted magnitude of terrestrial C by at least one order of magnitude. Reference of a 2017 paper. Reference of a 2017 paper is given here. A low-cost direct space experiment has been proposed in two papers in 2009 and 2016 for verifying the EGR or RRT-predicted value that verifies the 9th significant digit as compared to the 1983 adopted terrestrial C of CR in space at locations under the influence of strong solar gravitational field of Mercury or Venus, where the EGR predicted magnitude of C is respectively equal to 299792465 and 299792462 meter per second, which are higher than the 1983 adopted standard value of C, respectively by 7 or In response to a private communication in November 2015, Professor John L. Hall, Nobel laureate physics in 2005 of Gila, Nice, USA, after reading the manuscript of our space experiment paper, stated that your experiment for detecting delta C can be effectively done soon on the Earth with the linked network of standards from Brunswick, Germany, down to the Italian Standards Lab in Torino and the European Laboratory for Nonlinear Spectroscopy, LENS, and similar international fiber network being built by European colleagues which can compare clocks with unprecedented precision. His prophecy came true too soon and we could get for the data for the following lab-based proofs for delta C. First one is the same Brocchiatal, we have talked about it before, that was conducted to determine the delta frequency difference between LSM lab and in-rim lab. It came to the value was determined by them to 48 hertz, and the easier computed value of the frequency difference corresponding to this elevation of 1 kilometer between LSM SR clock and in-rim clock was computed to be 48.050 hertz, which provides the direct experimental proofs for easier in the hertz millihertz domain. Going back to the first column on MDW model, Misner-Thorne-Wheeler model. It can be said that second generation GR continues as MDW model, as is clear from the last paragraph from preface by the three authors of their 1971 book titled Gravitation. But just like Barman did not carry forward the Einsteinian concept of variable C, the so-called MDW model published in as the book titled Gravitation also did not carry forward the Barmanian concept of serious complications in the concept of observable quantities, as mentioned in his 1968 book titled Riddle of Gravitation. Because of its adoption of the principle of general covariance, this book on gravitation does neither mention as reference about Bartman's 1968 book titled The Riddle of Gravitation, nor mention about the importance of numerical simulation of the gravitational problem of n bodies in solar system using space age rendering data. Some proponents of GR conventional model are considering the three-body problem as one of the bigger problems in astrophysics. A more practical way to solve the problem is to use numerical methods. There are some who are stating that the three-body problem simulated orbits are unstable and chaotic, but in our more than a quarter-century long experience of simulation of celestial orbits, it can be said that to improve the situation, to improve their simulation codes, they need to work on the lunar orbit and match its sub-millimeter positional accuracy. Their statements that the three-body simulated orbits are unstable and chaotic are due to the fact that they are either fixing the center of their frame at the center of mass of the body instead of the center of the relevant nature's preferred frame, and are not following nature's way to conserve energy and momentum, or not using a real orbital model in which the elliptic orbit recesses over the orbital plane, that is undergoes theta rotation, causing the rotating ellipse, whereas the orbital plane simultaneously swings due to its phi rotation, causing variation of inclination of the orbital plane with time, or not adopting the fact that for all real orbiting bodies or systems, nature does always conserve energy and momentum, both magnitude and directions, in the polar coordinate system, that is r theta phi, instead of the Cartesian coordinate system x, y, z. Other details. constancy of GR conventional model had already been invalidated experimentally by the detection of delta C as preposition delta nu, as we have talked earlier about theater paper. Due to the elevation frequency, this has been proven by many other labs. We have referenced it elsewhere. So constancy is not, it has been proven experimentally that constancy is not Einstein-preferred. Means constancy is not an Einstein-preferred concept, and experiments are proving now that Einsteinian contention is very correct. Next bullet, the James Webb Space Telescope observes the universe in infrared light, which is invisible to the human eye, and is capable of detecting the faint light from the ancient stars and galaxies by peering into the distant universe. The observatory can essentially see back in time to about 13.5 billion years ago. Scientists have determined that the universe is about 13.7 billion years old. These objects are way more massive than anyone expected, stated study co-author J.Bernstein, assistant professor of astronomy and astrophysics at Pennsylvania State University. Reference is given here. She further stated that we expected only to find tiny young baby galaxies at this point in time, but we have discovered galaxies as mature as our own in what was previously understood to be the dawn of the universe. The revelation that massive galaxy formation began extremely early in the history of the universe appends what many of us thought was settled science. The galaxies are so massive that they conflict with 99% of models representing early galaxies in the universe, which means scientists need to rethink how galaxies formed and evolved. One renowned author of GR conventional model explains equivalence principle by stating that it means to say that the gravity equals acceleration. After all, you all know that if you are in an accelerated frame of reference, say a rocket ship or an elevator accelerating downward or upward, you feel an effective gravitational field. Even children know this because they feel it. Of course, children can feel acceleration, but the biggest fallacy in this regard is that even grown-ups will not be able to differentiate between the two types, that is acceleration of an elevator and that of a gravitational field. However, such argumentation was only okay for relativists of pre-space age, but in the space age, relativists who have done celestial or computation cannot accept such arguments because of the following reasons. In the accelerated leap, the acceleration is precisely the same everywhere, and the vector direction of acceleration at different points of an accelerated frame coordinate system are precisely parallel. Whereas in a gravitational field, the magnitude of the acceleration varies from point to point, and the vector directions of gravitational acceleration at different points are radial and never precisely parallel. All the way from the origin of the natural coordinate system or frame. The degree of this variation is so much that such approximation is not acceptable for the precision demanded by celestial orbit computations in space age. The above shows one of the reasons to state that it is time for them to get their GR model verified for planetary and lunar orbits. More particularly, to get their GR model compute the sub-millimeter positional accuracy of the moon. Dr. Neil Turok, an internationally renowned cosmologist, stated during his YouTube lecture titled "The Secrets of the Universe," delivered during September 2023, that this is nothing but a story. All of physics is a story. Physics is a narrative. Perhaps it can be said that physics started becoming story since 1912, when Einstein had no other option but to accept the concept of relativity of all frames in GR. But to incorporate the curved space in GR, and he stated that there is no way of escape from the consequence of non-Euclidean geometry if all frames are permissible. However, he stated in his first dictum for future generations that grand aim of all science is to include the largest possible number of empirical facts by logical reduction from the least possible number of hypotheses. Now, in the space age, it is the Proponents of easier model achieved their goal of convergence of their simulation programs using precision spacage data of the planets and the moon with relativistic time. Einstein's concept of variable or coordinates value of C, that is CR, coordinate value of C, that is CR, infinite propagation speed CG of gravitational interactions. Recent spectroscopic observations reported anomalous redshifts regarding the Seyfert galaxy NGC 7603 and its companion galaxies, which are apparently connected by a luminous filament. The redshift of those two galaxies are 0.029 and 0.057 respectively, whereas the luminous filament there are two compact emission line objects having respectively 0.243 and 0.391. According to EGR, such anomalous redshifts are mainly the consequence of high value of CR equal to respective EGR estimated order of magnitude values 350 and 400,000 km per second on the emitting surface of the compact objects as compared to CR on the emitting surface of the stars belonging to the NGC 7603 and its companion galaxy. Professor Sergei Kopeikin stated in his 2007 paper that attaining the level of 1 microarc-second positional accuracy and better would completely revolutionize fundamental astrometry by merging it with relativistic gravitational physics. Proving his prophecy, EGR has already achieved 0 microarc-second and 1 order of magnitude better for the 5 inner solar system planets and the moon. In the enlarged tabular data presented near the end, as EGR is the relativistic gravitational physics powered with variable C, Euclidean geometry and relativistic time. Reference 2019 paper is given here. For obtaining higher levels of precision, EGR revealed that other important necessities are to use the appropriate nature's preparation for any particular celestial body, that is the SCSA or solar system planets, that is the SCSA for the solar system planets and the ECSA for the moon. And number 2 bullet, the polar CS R theta pi instead of the Cartesian XYZ coordinate system, since nature uses a real orbital model in which the elliptic orbit precesses over the orbital plane that is undergoes theta rotation causing the rotating ellipse, whereas the orbital plane simultaneously swings due to its pi rotation causing variation of inclination of the orbital plane with time in the appropriate nature's preferred frame of the orbiting body, as is simultaneously and precisely conserves the orbital angular momentum according to the conservation law of angular momentum m theta and m phi corresponding respectively to the theta and phi rotations. The data of the orbital precision theta p and the lunar orbit computed by all three methods during several typical orbital cycles from a LESMA expansion is lunar determinants at sub-microarc-second accuracy. From a LESMA run using the simulation model has been presented in table 2 below. The simulation models for the linear determinants incorporates two features or concepts, namely the relativistic time for integration and the proven orbital model that incorporated the pi rotation of elliptic orbit. This also proves the important fact that the powerful spacage tool of numerical simulation verifies at the level of experimental or observational precision all the equations, concepts that includes any chosen model, mathematical, orbital, etc. and data that go into a successful simulation. And this efficient tool shows up with the experimental or observational results. Whereas in case of a major error, the numerical simulation program does not converge at all. Table 2, lunar positional accuracy and orbital precision computed from lunar ephemeris LESMA. The enlarged view of table 2 is given near the end. The sub-microarc-second match of theta p obtained from the third method with the theta p derived from the second method utilizing the conservation law of magnitude of the orbital angular momentums are checked for hundreds of lunar orbital cycles. Such close match proved that the selected orbital model is the real orbital model that has been adopted by nature nature for its methodology for conservation of linear and orbital angular momentum, that is both n theta and n phi in a polar coordinate system r theta tau. Numerical integration to yield an ephemeris in EGR is similar to JPL for determining the magnitude of radius vector RHO. But we have developed an alternate way based on the real orbital model to compute a second value of RHO. And dipro given in the table, last but one column, is the difference between these two values that gives us a measure of the inaccuracy level in computing RHO or rho. Utilization of this real orbital model has revealed hitherto not so well understood feature of the orbital model. Hitherto not so well understood feature of the lunar orbital motion that relates to the fact that the orbital velocity vector d, even after vectorial subtraction of the radial velocity dr, has two mutually perpendicular components d theta and d phi or d phi, directed respectively towards the theta and phi directions. Note, for example, variations of d phi is of the order of -3 to 6 plus 6 meter per second as compared to VR magnitude of 68 plus 68 to -40 meter per second during the epochs of a typical lunar orbital cycle, and the variation of d phi or phi d phi governed by the corresponding conservation of laws of magnitude of angular momentum m phi leads to the variation of inclination of the lunar orbital plane with time, and the incorporation of the methodology of conservation of magnitude of the angular momentum m phi and phi rotation of the orbital plane led to considerable improvement in the precision level of the ephemeris. It may be mentioned that theta rotation leads to the orbital precession and rotating ellipse. A plot showing cyclical variation of d phi or d phi, the ending periods of lunar orbital cycles over 815 orbital cycles in meters per second has been depicted in figure 1, starting from 8608 cycle, the 8th orbital cycle of the year 1986. Result obtained from a multi-cycle computational run, which is depicted near the end of this presentation and which reveals that magnitude of d phi or d phi varies cyclically from a minimum of -10.3 to a maximum of 7 meter per second. Accuracy check of Lesma. Before that, I will just point to the cyclical variation of d phi or d phi, that at the ending perigee of a lunar orbital cycle over about 815 orbital cycles starting from 8608 cycle, the 8th orbital cycle in the year 1986. And above this is given the table 2, which was not readable there. It is given here in much more readable format. The mismatch in orbital precision can be seen in micro-arc second. Everything is less than 1 micro-arc second, in fractional micro-arc second. And positional accuracy dipro in millimeter, everything is less than, is fractional millimeter, less than a millimeter. In all the cycles, there are many cycles here, 8608, 9, 10, 8810, up to 2202, several cycles are there. Accuracy check of Lesma. Accuracy check of Lesma has been done by comparing with JPL ephemeris D405. It revealed that JPL is leading to taller and wider diplo error patches than Lesma. In this paper, we computed and presented data for 7 contiguous orbital cycles. These are presented at the end in 3 figures 2ABC, which revealed that lunar ephemeris data from JPL's D405 led to sub-millimeter diplo error for only 4 orbital cycles, whereas in the other 3 orbital cycles 8610, 8613 and 8701, the highest values of diplo errors are respectively 46, -46, -34 and -156, whereas lunar ephemeris data from EGR are sub-millimeter for all 7 contiguous orbital cycles. This is shown in the last sheet. Figure 2a, it is showing Lesma for 7 orbital cycles according to EGR, the dipro error is within plus 1.0, minus 1.0, all 7 cycles. But for JPL Epimeris D405, when it was plotted, it was found only 3 are visible. Less 4 are, because they are too big errors, plus 52, minus 200. Actually the last one is minus 156 millimeter. Whereas others are sub-millimeter, other cycles. So they have become like a line. So what we did to understand how they are varying, we have drawn a special figure in which those 3 big cycles, big deep row error cycles have been eliminated. So there the other cycles are showing up. Some are very small, near 0 and 0.5, but some are about little more than 1.4, about 1.4 or so. EGR is using the relativistic transformation factor for time, formulated in 2007 and employed in RRT or EGR in their paper published in 2007. Happens to be identical to that developed later by JPL in their 2016 Deep Space Atomic Clock mission and presented in a JPL Deep Space Atomic Clock progress report. Reference is given here 2016 with link. EGR and JPL etc. It may be noted here that relativistic time is Einstein-preferred. EGR and JPL etc. using infinite propagation speed CG of gravitational interactions, but we determined that at the present level of observational accuracy, the lower limit of CG is 17 million times C from the presently available accurate observational data for the solar system planets, which compares well with that determined as 7 million times C by Laplace in 1805. References paper in a book published in 1805. EGR adopted the nature's preferred frame of the orbiting body, say geocentric lunar orbit, and found sufficient reason to give up relativity of all frames and adopted and proved that space is Euclidean by matching angular precision at sub-microsecond accuracy using 3 independent methods. Reference is 2019 paper. We have identified and computed the 5 rotation of the orbital planes of lunar and planetary orbits, which led to the 3 orders of magnitude accuracy improvement in the magnitude of orbital precision of the planets and the moon. Dr. Kiefer Mittman of Caltech stated in his YouTube video titled "The Universe Never Forgets," with link is given here, that there is no inherent reason why Einstein's theory of relativity has to be correct theory that describes gravity within our universe. It could certainly be something very similar to Einstein's theory, but there is no reason it has to be exactly Einstein's theory. And so it turns out actually that if you study physics long enough, you realize that Einstein's theory has to be wrong at some point because it's inconsistent with the physics we use to describe the microscopic realm, namely that of quantum mechanics. Conventional model. Recent generation of the proponents of conventional model. Reference Okawa. Reference is given here. State that they are investigating GR minimally coupled to a massive scalar field at the nonlinear level by performing full-blown numerical simulations. They are stating that they expect supermassive black holes SMBHs with 10 to the power 6 to 10 to the power 9 times the solar mass to be hosted at the center of most galaxies, and in fact observational trajectories of stars close to the center of Milky Way can hint at our very own SMBH with a mass of 4.2 million, many of the with a 4.2 million mass of the Sun. Many of the aforementioned observations ranging from the radio to the X frequency band allow for accurate estimates of the mass and spin of these black holes, BH, thus making precision black hole physics possible. This in turn allows a mapping of compact objects across the visible universe with second generation ground-based gravitational wave observatories. A vast majority of more than 3,000 videos on general relativity in YouTube describes their concepts of curved space that they have learned from textbooks and similar sources, but not even one talk on making use of numerical simulation for the gravitational problem for computing sub-millimeter or better positional accuracy of the moon with respect to its nature's preferred frame or any other frame, though their recent generation uses numerical relativity for some other jobs, and on computing the frequency shift of terrestrial clocks due to shifting from a laboratory at a lower elevation to a laboratory at a higher elevation on the Earth, which is an experimental proof for Einstein's concept of the variable velocity or coordinate speed of light. Variable or coordinate speed of light is the Einstein-preferred concept. Pontian et al. Reference of that paper is given in monthly notices of Royal Astronomical Society. Is already working on cosmological n-body simulations. They need to extend their work for solar system, planets and the moon. Since their recent generation, which may perhaps be called the fourth generation GR, is already performing full-blown numerical simulation that will make precision black hole physics possible, they need to also work on the gravitational problem. They also need to work on the gravitational problem for computing sub-millimeter or better positional accuracy of the moon with respect to its nature's preferred frame or any other frame using precision space age data. Thus, they would be able to find that naturally preferred that nature's preferred frame is the only choice for high precision celestial orbits of the solar system, planets and the moon, and thus get rid of the non-Euclidean or curved space and bring back Einstein-preferred Euclidean space in their conventional model. Symplectic integrators developed in the mathematical celestial mechanics community are now used nearly ubiquitously in dynamical simulations of the solar system, galactic systems and cosmology. These symplectic integrators developed by the mathematical celestial mechanics community for dynamical simulation of the solar system, etc., do not incorporate the methodology for conservation of linear and orbital angular momentums, that is both m0 and m5, in a polar coordinate system. The best check for their efficacy is to use them to match the sub-millimeter positional accuracy of the moon. Astronomers model. Proponents of their astronomers model arrived at their goal for achieving the convergence of their simulation programs using precision space-age data of the planets and the moon with non-relativistic time. For matching the sub-millimeter positional accuracy of the moon, they need to use the relativistic transformation factor for that time as they have used in 2016 for Deep Space Atomic Clock mission, DSS mission, as presented in the JPL Deep Space Network progress report. It mentions the relativistic time is Einstein-preferred. Next bullet, the special relativity concept of constancy. This needs to be changed to variability according to Einstein's theory. Constancy is not Einstein's preferred. Next bullet, using the nature's preferred frame of the orbiting body, they have already used the geocentric lunar orbit. This will help them to replace the concept of relativity of all frames with nature's preferred frame and confirm that the space is Euclidean. Euclidean space is Einstein preferred. We hope that, as mentioned in the left-hand side column, the further future work by the fourth generation GR, and as mentioned in the right-hand side column, the future work by the proponents of GR astronomers model will help merging all generations of GR into one Einstein-preferred GR. They need to incorporate the nature-adapted orbital model because of the fact that for all real orbiting bodies or systems, nature does always conserve energy and momentum, both magnitudes and directions in the polar coordinate system, r-theta-phi. This will help them to achieve sub-millimeter positional accuracy of the moon and help GR astronomers model become Einstein's GR. They need to check that the computed values of star column, the further future work by the fourth generation GR, the fourth generation GR, and as mentioned in the right hand side column, the future work done by proponents of GR conventional model and as mentioned in the right hand side column, the future work by proponents of GR astronomers model will help merging all generations of GR into one Einstein-preferred GR. With this, I conclude my presentation